Okay, let's do the last one in the exponential functions category. So it says find the equation of the tangent line to the graph of the function y equals 3 raised to the x minus 4 at 4, comma 1. All right, so if I have y equals, oops. So I have y equals 3 raised to the x minus 4, y prime is going to be, you remember, if I had 3 to the u, the derivative of that is 3 to the u times whatever the derivative of u is, times natural log of 3. All right, so it's going to be 3 to the x minus 4. The derivative of x minus 4 is just 1, so that means that, and then times the natural log of 3. So that means my slope at 4, comma 1 is 3 to the 4 minus 4 times natural log of 3. 3 to the 0 is just 1, so it's just natural log of 3. So my slope is natural log of 3 through the point 4, comma 1. 1 is not your y-intercept, so it's not your b-value. So you have to do y minus y1 equals n times x minus 1. So m is the natural log of 3. X1 is 1, or sorry, x1 is 4. Y1 is 1. And I would leave your solution like that on the test. You can always simplify, but if you messed up in your simplification, you would not always type. So that's the end of that one. Okay, I'm going to go ahead and move on to the next category. So logarithmic functions. So find the derivative of each function. Now when you see this one, you could do it where y prime is just equal to 2 times 1 over x plus 5 times derivative natural log of 3x is 1 over 3x times 2. And then you can simplify. So it's just 2 over x plus 15 over 3x, or the 3 is going to cancel, so you see it's 5 over x. They have common denominators, so it's just 7 over x. That's pretty easy. Or you can combine to begin with. So you could notice that y is just going to be the natural log of x squared plus the natural log of 3x to the fifth. This looks a little bit messy. 3 to the fifth is 343, so it's a natural log of, since they're separated with plus, it's x squared times 343x to the fifth. Which is natural log of 343x to the seventh. And then you can do the derivative from there. So if that's what y is equal to, your derivative is 1 over 343x to the 7 times the derivative of that, which is 7 times 343x to the 6. So the 343's cancel. So it's just 7x to the 6 all over x to the 7, which is 7 over x. So you can choose your battles. Personally, I think it's easier when they're separated into 2 separate logarithms than combining and then taking the derivative. So it's also true, when we talked about logarithmic differentiation, that's why we separated into separate logarithms. So it wasn't a huge mess as we're trying to derivative. All right, so f prime of x. So let's think about this then. If I'm going to separate into separate logarithms, this would be log base 3 of x minus log base 3 of 2x plus 3. Well, log base 3, we don't like to switch the derivative of that. Let's switch to natural log. So it's going to be natural log of x divided by the natural log of 3 minus the natural log of 2x plus 3 divided by the natural log of 3. The natural log of 3 is just a number, so you can just pull that out to the front, so 1 over natural log of 3. And then what we'll be taking the derivative of is just the natural log of x minus the natural log of 2x plus 3. Okay, so that's simplifying f of x. So that's all f of x. So f prime of x is, keep that number out front, just like, you would keep 2 for something out front, times the derivative of what's inside. So it's 1 over x minus 1 over 2x plus 3 times the derivative of 2x plus 3, which is 2. So So you get 1 over the natural log of 3 times 1 over x minus 2 over 2x plus 6. And I would leave it like that. I probably wouldn't try to get common denominators. I wouldn't even multiply the natural log of 3 in. That's your answer. The next one. Find the equation of the tangent line for the function y equals log base 3 of x over 27, 3. Same kind of thing. Y prime, you can rewrite y equals log base 3 of x. I always rewrite because I don't memorize all the formulas. I just know for natural log. So I know that this is natural log of x all over the natural log of 3. And natural log of 3 is a number, so I can write 1 over the natural log of 3 out front, and I'm really just taking the derivative of natural log of x. So y prime is 1 over natural log of 3 times 1 over x. Now, a lot of you guys in class are really confused about the pulling the 1 over the natural log of 3 out and all of that. When you think about if y was equal to 5x to the 7th, we just leave that 5 out front. All we're taking the derivative of is the x to the 7th. Would be 5 times 7x to the 6th. And then we multiply those numbers. That's what we're doing here. We're just pulling the number out to the front, and that's it. Okay, so now if I'm finding the slope, my slope is at x equals 27. So it's 1 over the natural log of 3 times 1 over 27, which is a very nice number. So it's going to be, I don't know, maybe 27 natural log of 3 like that, which is 3 to the 27 if you wanted to write it as a power, which is really gross, but we'll go with it. So we get y minus y1 is 3 times m, so I'll leave it as 1 over 27 natural log of 3, x minus x. That would be your answer. Integration problems. All right, so when I look at this first one, a lot of you guys might think it's going to be a u substitution because there's a denominator, and a lot of them in class that we did had denominators like that. This actually isn't. We're just going to pull the x cubed in both pieces. So it's 5x over x cubed becomes 5 over x squared, which is 5x to the negative 2, plus this is 7x to the negative 1, or 7 over x. I'm going to leave it like that because those are the most familiar terms, or most familiar forms. Now, when you're integrating this sum, I mean, you can just break it up so it's 5x to the negative 2 dx plus 7 over x dx. This is what I'm doing in my head, though. I'm not actually writing it in separate pieces. So this is, I'm going to add 1 to the power, so it's x to the negative 1 now. The 5 was kind of just like on the outside of the integral, it doesn't matter. And I have 1 over my new power, so 1 over negative 1 to the negative 1, so negative 5. And you can check when you take the derivative, negative 1 goes with that, and it's positive 5. Negative 1 subtracting 1, you get negative 2. So that is right. Plus 7 over x, so that's 7 on the outside with 1 over x on the inside. So 7 natural log of the absolute value of x, and then plus c. Make sure you have your absolute values. We don't know anything about x. You didn't say that it was greater than 0 or anything, so you need your absolute value. All right, now this next one is a u substitution. So if I let my u equal the x squared plus 5, du is 2x dx. That means 1/2 du equals x dx. That's this part, x dx. So when I'm replacing, I have 1 over u du, the 1/2 out front. So when I integrate, this is natural log of the absolute value of u, the 1/2 out front, plus c. Which is 1/2 natural log of x squared plus 5, and absolute value plus c. And then if this is a multiple choice question or something, you would actually not even need the absolute value because x squared is always positive, so x squared plus 5 is always positive. So they would probably write it like this without the absolute values. So don't be thrown off by that. Don't say, oh, no, it has to have absolute value. You can actually add that. All right, this one is 5 to the x. So 5 to the x, when I integrate it, it's 5 to the x over the natural log of 5. I'm going from 0 to 2. So 5 squared over natural log of 5 minus 5 to the 0 over natural log of 5. So 25 over natural log of 5 minus 1 over natural log of 5, which is 24 over the natural log of 5. I would leave your answer like that, but if you really wanted to see what it is as a decimal, so if you guys had a decimal answer, it would be like 14.912.